Hello everyone, welcome to EnviroPioneers. In this video, we will learn the concept of temperature inversion. Inversion is a fundamental concept in meteorology and climatology and is also very relevant for the environmental science, especially in the air pollution and the weather studies. As we learned in the video of the lapse rate that there is temperature gradient in different layers of the atmosphere, and this rate of change of the temperature with height, it is referred as the lapse rate. And when we talk about the troposphere, which is very important layer in the meteorology, the definition of the lapse rate is the rate at which temperature decreases with height in the atmosphere and is given by this formula, that is minus dt by dz. And this lapse rate is considered positive when the temperature decreases with elevation. It is zero when the temperature is constant with elevation, and it is referred as the isothermal condition. And this lapse rate is negative when the temperature increases with elevation, and this is referred as the temperature inversion. So normally we have the inversion condition in the stratosphere, and this is referred as the stratospheric inversion. But in the troposphere, this is the normal condition. Means we have the warmer layer of the air near to the earth, and as we move up in the altitude, we have the colder air. So we can see this is warmer to cooler condition. And the lapse rate for this is given by the blue line. That is, the temperature decreases with the elevation. But if a shallow layer of the warm air is formed in the atmosphere, the normal pattern is disturbed. Now we can see in the lower troposphere we have the cooler air, beach mein we have the warmer air, and up in the atmosphere we have the cooler air. And this shallow layer of the warmer air, it is referred as the inversion layer. And here is the base of the inversion layer, and this is the top of the inversion layer. Now, if we see the lapse rate for the temperature inversion, so from the ground to the base of the inversion layer, we have the normal lapse rate, means the temperature decreases with height. But as we have the inversion layer, we have the increase of temperature with height to the top of the inversion layer, and after that again we have the decrease in the temperature with the altitude. So this temperature inversion is defined as a meteorological phenomena where the temperature of the air increases with the altitude, and this is the reverse process of the normal behavior of the temperature in the tropospheric layer. In normal condition, the warm air mass or these parcels, they rise up in the atmosphere when they have the colder condition in its environment. But in the case of the inversion layer, these rising air parcel, when it reaches to the base of the inversion layer, the temperature of this air parcel is less in comparison to the temperature in this inversion layer. So these air parcel, when they are rising into this inversion layer, they are cooler than their surrounding environment. Thus, this inversion layer, it inhibits their ability to ascend up. As this surface based air parcel are not able to rise freely through the atmosphere, they get accumulated in the lower layer of the atmosphere. Thus, the temperature inversion, they act as lids that prevent the rising motion, and it traps the air pollution near to the ground, as we can see in these two images. As the temperature inversion limits the vertical movement of air, it also restricts the cloud development and precipitation. And if the air below the inversion layer reaches the dew point temperature, we can have the formation of the dense fog, and also this trap the air pollutants near the ground, worsening the air quality. Now, there are two main types of inversion. One which occur near to the surface, and other which occur up in the atmosphere. So here it is mentioned that those that occur near the surface and those that develop aloft, means which occur above in the atmosphere. So this is the normal condition where temperature decreases with the altitude. Here we can see near to the ground we have the temperature increase with altitude, and after the top of the inversion layer we have again normal pattern, that is temperature decrease with altitude. And in the third case, here we have the temperature decrease up to the base of the inversion layer. Then we have the temperature increase, and after the top of this inversion layer, again we have the normal pattern, that is the decrease of temperature with altitude. Depending upon what factors are responsible for formation of inversion layer in the atmosphere, this inversion may be classified into the ground inversion, valley inversion, frontal inversion, marine inversion, subsidence inversion, and turbulence inversion. And among these, the ground, valley, frontal, and marine inversions, they occur near the surface. And the subsidence inversion, it develops above in the atmosphere, and this turbulence inversion may occur either near the surface or it may develop above in the atmosphere. I have put the asterisk mark to the turbulence inversion because it may fall in either of this category. So let us learn each of these inversions in detail. So first is the ground inversion or the radiation inversion, which is also known as the surface temperature inversion or the nocturnal inversion. If you see these names, they are interrelated. First, let us see the definition of the ground inversion or the radiation inversion. So, this inversion occurs when the ground cools rapidly by radiating the heat to the sky at night, causing the air directly above it to become colder than the air higher up. As we can see in this image, the ground, it emits the radiation during the late evening or in night, and it becomes cold, and the air which is in immediate contact with this surface, it will become cool, and above in the atmosphere still we are having the warm air. So here if we see the cool air and then warm air, so as we move up in the altitude there will be inversion because temperature is increasing with altitude. So the inversion which occur in night due to the surface temperature of the ground which become cold by the radiation process, that is the ground inversion or radiation inversion or surface temperature inversion or nocturnal inversion. If you remember this graph from the video of temperature, solar heating, it produces the high surface temperature during the afternoon, and after sunset the earth's surface, it loses energy through the radiation, and the air near the surface, it get cool through the conduction. As the air is the poor conductor of heat, the air above in the atmosphere, they remain warmer in comparison to the air near to the surface. So, in the radiation inversion or the ground inversion, the radiation from the ground on the clear night, it causes more rapid cooling at the surface in comparison to those that higher in the atmosphere. Thus, we have the increase of temperature with the altitude, and from the top of the inversion layer, again we will be having the normal lapse rate, that is temperature decrease with the altitude. So here are some of the important points related to the radiation inversion or the surface temperature inversion. It develops when the air is cooled by contact with the colder surface until it becomes cooler than the overlying atmosphere. And this inversion layer, it can be formed very near to the earth surface or slightly above in the atmosphere. So depending upon at what height this inversion layer is formed, accordingly we will be having the lapse rate. And this radiation inversion, it occurs most often on the clear nights when the ground cools off rapidly by the radiation, and if the temperature of the surface air or the air below the inversion layer, if it decreases below the dew point temperature, fog formation may also occur. And this radiation inversion or the ground inversion, it is very common in the higher latitudes, and in the lower and middle latitude it occurred during the cold night, means in the winter season, and it dissipate after the sunrise. These are the suitable conditions for the radiation inversion. Means it is more prominent in the clear, cloudless skies because it leads to faster cooling of the ground. Because if there are clouds, they absorb the terrestrial emission and they block the Earth's heat from escaping. Second condition which is mentioned here, that is long winter nights, because if it is a long night, it will provide more time to lose a significant amount of heat through the radiation. Third condition is mentioned, calm and stable air, because in this condition there is no horizontal or vertical mixing of the air and it allows the cold air to accumulate and remain trapped. Presence of dry air is also suitable condition for the radiation inversion, because if the air is containing water vapor or moisture, water vapor is a very good absorber of the long wave infrared radiation which is emitted from the earth surface. Thus the dry air, it allow more heat to escape into the atmosphere in comparison to the moist air. And the fifth condition which is mentioned, that is cold or the snow covered ground, because this will be responsible for cooling of air at the faster rate. And this surface temperature inversion or the radiation inversion which is formed in the atmosphere, they are generally shallow, but they may be of the greater depth in the regions where the land surface is uneven. When we are saying greater depth, means we are talking about the thickness of the inversion layer. Next is valley inversion. This phenomena occurs in the mountains and the valleys where cold, dense air sinks under gravity to the valley floor while the warmer air, it remains aloft, creating a temperature inversion. If you remember this from the video of temperature, that elevation, it significantly affect not only the mean temperature but also the daily temperature range. Here we saw that because of the reduced density at the high altitude, the overlying atmosphere, they absorb and reflect a smaller portion of the incoming solar radiation, and the intensity of the solar radiation increases, resulting in the rapid and the intense daytime cooling, while during the night time, cooling also occurs at the accelerated rate. So, at the top of the mountain or higher in the elevation, the air become cold at the faster rate. So this cool air mass, it sinks down the side of the mountain, यानी कि इस mountain के side से ये flow होते हुए नीचे आएगा. So as it sinks along the side of the mountain, it gets accumulated in the floor of this valley. As we can see here also, the cold air mass, it sinks down the side of the hill, and as this cooler air is denser in comparison to the already existing air mass, so it displaces the warmer, less dense air mass up in the atmosphere. So here it is mentioned that warmer air mass, it is forced upward and it is sandwiched between the two cool air masses. So here we have the colder, denser air mass, and above in the atmosphere, we have the cool air mass that is forced upward because of this displacement, and in between these two, we have the warm air mass. As this cold air is denser than the warm air, the chilled air near the surface, it gradually drains from the upland and the slope, and it gets accumulated into the adjacent lowlands and the valleys. So here we can see from both sides we are having the cold air flow, and here we are having the pool of cold air. So when this is accumulated, it displays the warmer air upside, and these valleys, they experience relatively thick surface inversion, which is also referred as the deeper surface inversion in comparison to the normal terrains. And this type of inversion does not dissipate quickly after the sunrise, means इसको खत्म होने के लिए जो normal inversion है उससे ज़्यादा time लगता है. As in this process we are talking about the drainage of the cold air, means the air, it flows along the slope of the mountains as we have the drainage of the water. So this valley inversion, it is also referred as the air drainage inversion or the cold air drainage inversion, and as it occurs in the valleys, it is also referred as the intermontane valley inversion, means the inversion which occurs in the valley which is located between the mountains. So the meaning of intermontane is located between the mountains. Do you remember the frontal wedging from the last video where we discussed that air rises up in the atmosphere when we have the collision of air masses having two different temperature? So when we have the warmer air and the colder air moving from opposite direction at a particular place, the warmer air overrides the colder and the denser air mass because this cold air it acts as a barrier, and this boundary it is referred as the front. So this frontal wedging is also associated with the frontal inversion because it causes a layer of the warm air to spread over the cooler air. As we can see here also, this is the warm lighter air, and below this we are having the cooler heavier air or denser air. So, at this front between the warm and the cool air mass, we have the inversion condition, and this is referred as the frontal inversion, means inversion which occur at the front of the warmer and the cooler air mass. So, this frontal inversion it often take place in the temperate zone, and it causes the cyclonic condition which results in the precipitation. And this frontal inversion it is unstable and it is destroyed as the weather changes. In all other types of inversion, the inversion layer is formed nearly horizontal, but in the frontal inversion the inversion layer is having a considerable slope. And as we can see, if there is emission from any industry, this warm air it stops rising when it encounters the warmer air above. Next is marine inversion. It occurs in the coastal areas where the cool, moist air from the ocean is blown inland and it sits beneath a layer of warmer, drier air. It looks similar to the frontal inversion, but in the marine inversion, we are not having the collision of air masses coming from two different directions. But here, the cold air it displaces the already existing warmer air upside. So here it is mentioned that the ocean, especially in the spring, it cools the air above it, making the air dense and moist. And the prevailing winds, like the westerly winds, they blow this cool air towards the land. As this cold air is denser, it displaces the warmer and less dense air up in the atmosphere. So, this warm air, which is forced upward, it will rest above the cold, dense air. So, for this particular area, as we move up in the altitude, initially the temperature will decrease because of this cold air, but after a certain height, we will again see the increase in the temperature because of the warm air that is displaced from the land. Next is subsidence inversion. So to understand this, first let us understand the subsidence. So subsidence it refers to an extensive sinking motion of the air which is most frequently occurring in the anticyclones. So here in this image if we see, when we are having the convergence of the air mass up in the atmosphere, it moves downside towards the ground. So, this is the anticyclone condition. When we are having the convergence of the air mass on the ground, it is responsible for rise of air parcel up in the atmosphere, and it mainly occurs at the low pressure area. And up in the atmosphere, we have the divergence of the air mass. But when we are having the convergence of air mass up in the atmosphere, this air mass it sinks down in the atmosphere, and this subsiding air or sinking air it is warmed adiabatically, as we discussed in the adiabatic lapse rate, that when an air parcel sinks in the atmosphere, it is compressed because of the increasing atmospheric pressure, and the temperature of the air mass it increases. So the inversion which is related to the subsidence, it is referred as the subsidence inversion. So here we have the definition for the same: a temperature inversion which is caused by the sinking air, and it is generally associated with the high pressure system. Subsidence inversion is also called as upper surface temperature inversion because it occurs in the upper part of the atmosphere. It is also known as the adiabatic inversion because it is formed because of the sinking air, and as the sinking air compresses and warms adiabatically, it is referred as the adiabatic inversion. It is also classified under the mechanical inversion because it is caused by the large scale mechanical forces, means sinking air. So, this subsidence inversion is caused by the widespread air descending, which compresses and warms due to the increased atmospheric pressure. So the air at the higher altitude they become warm, while in the lower troposphere we are still having the normal trend, means we are having the warmer air near to the surface, and as we move up in the altitude temperature decreases. But because of the subsidence, the air at the higher altitude they are warmer than the lower altitude. Thus after a certain height we will see increase in the temperature. So, when we are having the inversion condition because of the subsidence, that is the sinking of the widespread air, it is referred as the subsidence inversion. Here we have another diagrammatic explanation for the subsidence inversion. Descending air is compressed and warms adiabatically, and due to this, a inversion layer is formed, means a warm layer is formed in the atmosphere. And within this inversion layer, we have the accumulation of the dust and haze above the base of the inversion. And below this inversion layer, the visibility is reduced, while at the top of this inversion layer, the visibility is normal, and accordingly we can see the temperature gradient. Initially we are having the positive lapse rate, then we are having the negative lapse rate, and again we are having the positive lapse rate. So this subsidence inversion, it is common under the large high pressure system. So we are having the belt of high pressure, so at these places this subsidence inversion is more common, especially over the subtropical ocean, and in northern continents it mainly occurs during the winter. And last is turbulence inversion, which is something related to the airflow or wind. So here it is mentioned that turbulence, it is an irregular motion of the air which results from the obstructions to the airflow. We will learn about the wind and wind speed in detail in the upcoming videos, but for now we should know that the wind speed it increases with height, and there is less wind speed near to the ground because of the friction caused by the obstacles on the earth surface. It may be natural or man-made. So when this wind encounters any solid object, a whirl of air is formed on the leeward side of the object, and this whirl of air it is referred as the eddy. So this eddy it can be formed near to the surface or above in the atmosphere, and the size and the shape of this whirl or the eddy it depends on the speed of the wind as well as the size and the shape of the object. So these eddies they create the turbulence in the atmosphere. As here we have the two examples, one which is generated because of this aircraft and second because of the mountain. And when the turbulence is caused because of any barrier, so within the turbulent layer, the vertical mixing it carries the heat downside and cools the upper part of the layer. So within this turbulent layer, the colder air mass is present at the upper side. But the air which is present above this turbulent layer, that is still unmixed, means it is still having the warmer temperature in comparison to the upper part of this turbulent layer. So at this altitude, as we move up in the atmosphere, we will find the increase in the temperature with the altitude. So this turbulence inversion, it occurs when a calm and the still air overlies the turbulent air. So because of the turbulent mixing, the heat is carried downside and the cold air mass is accumulated upside, and above this turbulent layer still there is unmixed warm layer. So because of this gradient we are having the increase in the temperature with height. These inversions which we studied are also classified under non-advectional inversions and advectional inversions. So non-advectional inversions are those which do not involve the horizontal air movement and are mainly caused by the vertical processes or lack of air movement. For example, radiation cooling of the ground or air sinking and compressing. So these include ground inversion, subsidence inversion, and the valley inversion. While the advectional inversions are those which are formed by the horizontal movement of the air, and it include the frontal inversion, marine inversion, and turbulence inversion. So these are the references for this video. First one is a reference of book, The Atmosphere: An Introduction to Meteorology. Some of the content have also been taken from these three websites. We will meet soon in the next video related to atmospheric stability. Thank you and best wishes.